We see this canopy as an intricate, interconnected web of life, a stable system where every species has found its place. From orbit, that stability looks like a permanent sanctuary, a world of liquid water and a nitrogen-oxygen atmosphere suspended in the dark. The early universe lacked this order. It began with an absolute expansion of energy, clouds of superheated hydrogen and helium surging outward into a void where time and space were only just beginning to take shape. 4.5 billion years ago, the young Earth was a molten wasteland. It had no oxygen to breathe and no solid ground to stand on, existing instead as a rotating sphere of liquid rock under a constant rain of asteroids. The modern environment hides these violent beginnings. Earth began as a planetary furnace, and every drop of water we have today was won through 1 billion years of geological upheaval. Early in its cooling process, Earth faced a total reset. A protoplanet named Theia, roughly the size of Mars, struck the Earth at a shallow angle, liquefying both surfaces and blasting massive amounts of debris into orbit. Gravity eventually gathered that orbiting ring of incandescent rock, cooling it into a single sphere, the Moon. The Moon's gravity acted as a massive anchor, locking Earth into a steady axial tilt and predictable rotation, bringing rhythm to the chaotic climate. Without this massive collision, Earth's tilt would have remained erratic, preventing the stable seasonal cycles that allowed complex life to eventually take root. Even with a stable orbit, Earth was still a dry, volcanic sphere. Water arrived during a period of intense bombardment as ice-rich meteorites melted on impact, gradually flooding the surface to create primitive oceans. These oceans were the site of massive chemical reactions. Highly charged lightning strikes passed through mixtures of methane and ammonia, providing the energy that reorganized these basic molecules into complex amino acids. There is also evidence that these building blocks arrived from above. Mars may have been habitable millions of years before Earth, allowing primitive cells to form before an asteroid strike carried them here. In the deep ocean, these molecules gathered inside fatty membranes for protection. Within these tiny bubbles, they began to link together into the first self-replicating chains of DNA. The transition from chemistry to biology required extreme conditions. Our genetic ancestors were forged by the heat of falling stars and energy of atmospheric storms. 2.5 billion years ago, Earth faced a total freeze. Temperatures dropped to -18 degrees Celsius, and ice kilometers thick encased the entire planet from the poles to the equator. Remarkably, life survived this period through intense volcanic activity. Huge eruptions pumped enough carbon dioxide into the atmosphere to create a greenhouse effect, forcing a rapid global thaw. This rapid thaw triggered a massive biological explosion. Organisms that survived the ice mutated and grew more complex, evolving into the first lunged creatures that gripped the rocky shoreline. Environmental stress acts as a strict filter for evolution. When the world becomes uninhabitable, it forces organisms to adapt through radical genetic changes or vanish. For 160 million years, dinosaurs occupied every major ecological niche. They were the dominant specialized hunters of the land, sea, and air, leaving almost no room for smaller mammals to thrive. That dominance ended in the Yucatan Peninsula. An asteroid 27 kilometers wide entered the atmosphere, striking the Gulf of Mexico with the energy of billions of atomic bombs. The impact ignited the atmosphere, raising surface temperatures to 200 degrees Celsius. Giant tsunamis flooded the continents, while massive earthquakes restructured the landscape, blinding and incinerating almost all life on the surface. In an instant, 3/4 of all species vanished. The only mammals that lived through the following months were small enough to hide underground, surviving on insects and roots. Mammals only moved into the open because the previous dominant species were removed. Without that asteroid, our ancestors would have remained subterranean scavengers forever. Our direct ancestors eventually moved into the African rainforests. They evolved to live in the canopy, where a steady supply of fruit and a thick forest cover provided total security. That security was shattered by tectonic shifts. The rising of the East African mountains blocked the humid monsoons, slowly starving the rainforests of the water they needed to survive. As the forests turned into open grasslands, Our ancestors were forced to travel long distances between the remaining trees. They adapted by walking upright, a change that freed their hands for tools and defense. Human intelligence and bipedalism are the specific results of a localized environmental collapse. We didn't choose to walk, we were evicted from the trees. Life has persisted through a history of liquid fire, global ice sheets, and cosmic collisions. Each of these catastrophes destroyed the old world to make room for something new. Today, humanity is shifting the planet's carbon levels and chemistry at a rate that matches a major geological impact. We are becoming the disaster that life has spent billions of years trying to overcome. Earth will continue to exist long after we are gone. Its history proves that the planet is durable enough to recover from any atmospheric or biological shift we trigger. The planet is not in danger, but our place on it is. We are currently creating an environment that we as a species are not adapted to survive. If we don't change, we will be the latest chapter in Earth's history of mass extinctions.